Hello, my name is Soyeon An. I will start the presentation for the exploring the latest topics in electrical engineering term project 1. I will proceed with the content according to these sections. My name is Soyeon An, and I'm currently a third-year student in the electrical engineering department at Kwangwon University. Last year, I served as the vice president of the Electrical Engineering Student Association at Kwangwon University, and I'm currently the head of the planning division of the Emergency Response Committee at the College of Electronics and Information Engineering. The topic I have chosen is memory semiconductors. I select I selected this topic because I want to explore various fields. First, I will discuss the concept of the supercycle in memory semiconductors. This refers to the periodic fluctuations in DRAM prices. Memory semiconductors generally experience cycle of prosperity and recession every 3 to 4 years. This can be observed in the accompanying data. As with general market principles, prices are determined by supply and demand, and trend prices are also influenced by these factors. Next, I will cover the concept of the chicken game. This is an aggressive strategy where companies lower trend prices even at a loss to increase their market share. After experiencing 2 rounds of the chicken game, only 3 companies remain. The onset of the chicken game closely aligned with supply and demand trends. The relationship between the chicken game and the supercycle is as follows. In 2007, Taiwan's companies began increasing production, leading to the first round of the chicken game. As a result, the German company Kimonda went bankrupt. Then in 2010, Taiwan's and Japanese company increased production, leading to the second round of the chicken game. This resulted in the bankruptcy of the Japanese company Avida, which was subsequently acquired by Micron. In 2016, there were many speculations about the supercycle, but the most likely cause of the increase in DRAM prices was the surge in server service centers, ended increased during the period. In 2020, the global economic downturn caused by COVID-19 reduced demand, and the supply environment also worsens. This page outlines the current state of the memory semiconductor market. The photo shows Samsung Electronics semi-annual report for 2024. According to this report, it can be determined that the current DRAM market has entered an upward phase. Next, let's discuss the future outlook. Before predicting the future, I will briefly introduce HBM. HBM is a type of memory that connects multiple DRAMs vertically to enhance data processing speed compared to traditional DRAM. If we think of memory as a data warehouse, the bandwidth is like a width of the load leading into the warehouse. A wider load allows more cars to pass at once, enabling the warehouse to extract large amounts of data simultaneously. High-performance GPUs required for AI technology needs to process a large volume of data at once, so GPUs require large bandwidth. The future outlook is as follows. As AI demand increases and data volume grows, there is a need to expand the data center. This can lead to increased demand for DDR used in data center. Additionally, the advancement of AI has driven the need for high-performance GPUs, which can increase the demand for HBM. A representative example is NVIDIA. Now let's look at career field in memory semiconductor. For this presentation, I interviewed a professional working in the memory semiconductor field. He works at Samsung Electronics and is part of a team focused on commercializing DRAM. When asked about recent issues in the memory semiconductor field, he identified HBM as a key issue. He mentioned that HBM is high value addition products with significant growth potential and increasing demand. He also noted that Samsung Electronics HBM project have a promising future. Next, let's discuss the diversity of layers in the memory semiconductor field. According to the interview, there are various layers available in this field. Fab, fab infrastructure layers involve building infrastructure for effective product productions. Equipment engineer ensure the smooth operation and efficiency of equipment. In development labs, layers focus on designing DRAM and flash chip, creating layouts, and developing manufacturing process. Finally, he advised that focusing only on one layer can limit opportunity. It's better to explore various subjects before making a decision. For instance, he switched from circuit design to evaluation and analysis, which would have been challenging if he had focused solely on circuit design. As a graduate of Kwangwon University's electronic engineering program, he recommended studying broadly and carefully reviewing job description to match your skills and interests. Lastly, in the section of famous professor and university labs in the field of memory semiconductor, I have chosen Professor Hanu Jung. He is a professor in the Semiconductor System Engineering Department at Kwangwon University and conducts research in the field of memory semiconductors. His, his research encompasses a range of topics within memory semiconductor, not limited to embedded memory circuit design. Additionally, he provided lecture on electronic circuits and machine learning through his YouTube channel, which have been very helpful to me. In conclusion, the topic of my presentation is a field that I was keen to explore, even though it was not my primary area of interest. Although I initially thought memory semiconductor were challenging, preparing for this presentation revealed many new and beneficial aspects. This electrical engineering topic exploration class has been an invaluable opportunity for me to delve into a field I wanted to explore, expanding my understanding and knowledge in area I had not previously considered. Thank you for your attention. Thank you.